Okay, in lab 13, we're going to look at oligopoly and game theory. We're going to look at a two-firm model under perfect competition, under collusion that results in the monopoly one-price model, and the Cournot model. The Cournot model is a strategic economic model. Now, to do that, we have to assume, for simplicity, there are only two firms, firm one and firm two. We got to assume they're identical. We don't want to overcomplicate it. They operate identical mines and operate identical distributions of lithium hydroxide. Their cost equations are given here. They're identical because the firms, again, are identical, right? So in order to do this problem, you got to modify this Desmos.com model, which is over here. And to do that, you copy the highlighted expressions, the highlighted mathematical expressions, to the Desmos model. If I got to find cost one and cost two, I'm going to replace this part of the cost equation with my versions of it. Since both firms are identical, I do it for both cost equations. I just want to verify that my cost equations are indeed correct. And it looks like they are. Okay, so I have my cost equation for firm one, and I got my cost equation for firm two. Okay. The next thing I need to do is I need to recognize that the market supply curve down here is derived in the neoclassical model from these two cost equations. And the way that happens is that we first delete the subscripts here. Again, the firms are identical, and they're going to behave identically. So you can drop the subscripts on the Q's. And then we're going to replace these Q's with capital Q divided by 2. Because remember, they're identical. So this is the market output, big Q. And firm one's Q is half the market. Firm two's Q is half the market. So we're going to replace this with big Q divided by 2. Replace that with big Q divided by 2. Replace that with big Q divided by 2. And replace that with big Q divided by 2. When we add the two resulting equations and do some algebra, we get the industry supply curve. Notice there's a 2 times each firm's fixed cost. This right here is the firm's fixed cost, right? So all we're doing is we're adding this fixed cost to that fixed cost, which becomes 2 times that fixed cost, right? And then the next part is 27.2 times big Q, right? So in this part, we're adding them together, which results in 27.2 times 2. But then we're making the substitution here, big Q divided by 2. So 2's cancel. So we end up with the linear term here, minus 27.2 Q, big Q, right? Then here, we're going to replace that with Q divided by 2, big Q divided by 2, and big Q divided by 2. We factor it out. We add the coefficients. We square the divided by 2. We get 4. And magically, we get this expression. 0.2 divided by 2 Q2, right? Now, I could have divided this by 2, and I could have written this more simply as 0.01 Q squared, right? But I didn't do that on purpose, right? Because when we differentiate this function with respect to Q, this part is gone, right? This part is constant. No matter what value Q is, this part is constant. So this does not change. So when you do a derivative, you're looking at changes in values. This value is that before and after some change in Q. So that part is 0. Then we got to move on to the linear part. When you differentiate a linear equation, you essentially just drop the variable, right? Because the old exponent is 1. When you do a derivative, you multiply the old coefficient times the old exponent, which is 1. So minus 27.2 times 1 is minus 27.2. And then what you do is you take the old exponent, 1 in this case, minus 1. 1 minus 1 is 0, and q raised to 0 power is 1. So that's why you end up with this 27.2. Now in the quadratic part, you take the old exponent and you multiply it by the old coefficient, which includes divided by 2. So when you bring this old coefficient out, the 2 divided by 2 is 1, right? And then you subtract off the 1 from the 2 and you get 1. So q raised to the first power is q. So that's why you end up with this term here, right? Now you don't have to do the calculus after, if you're interested, and you take calculus, and then you take intermediate microeconomic theory. You're going to do that kind of calculus in intermediate micro theory. You may, it depends on the teacher. A lot of teachers like doing the calculus in intermediate micro theory, right? So you'll learn how to do that in intermediate micro theory. I just wanted to illustrate that this marginal cost curve in neoclassical economics comes from adding up the firm cost equations. You add those two together, you do some algebra, then you take a derivative, and from these two equations, you get this market supply curve, okay? Now, the demand equation, we have to copy this expression. We have to find the demand equation in our Desmos model. I'm going to copy that expression and find my demand equation. And it looks like I have my demand equation's right here, right? Number 4. The reason why I call this demand is because notice the slope of Q is a negative 0.02, right? Minus 0.02. So this has to be the demand equation. And I'm gonna use my hotkey to do that. I was going to double check to make sure it is the same as my demand equation, right? Now, the demand model below gives how much consumers of lithium hydroxide are willing to pay for different quantities of lithium hydroxide. Right? That's what a demand curve is, right? It gives how much consumers are willing to pay for a given quantity or pay for different quantities. And as those quantities rise, it becomes less scarce and consumers are willing to pay less and less and less. As lithium hydroxide becomes more scarce, as Q declines, the value, the price rises. And that's the law of demand, right? Okay, I think that's, okay, let's see what we got here. We got our cost equation. I think we're good on the numbers that we need to bring in at this point. So in our competitive equilibrium, if you remember, in a competitive equilibrium, this equation here is our market supply curve, which is this one here, minus 27.2 plus 0.02 Q, right? So if you extend this down, it crosses the y-axis at a negative 27.2. Now this is the demand equation, and it crosses the y-axis at 179.2, right? And it slopes down. At the market equilibrium is determined by the intersection of demand and supply. This axis is price, this axis is quantity, this is supply, this is demand, and they intersect at these dashed lines, right? This dashed line is the market price, and the market price is $76, right? So graphically, visually, that looks like $76, right? The market quantity is split between the two firms. So firm one is mining 2,580 metric tons of lithium hydroxide, and firm two is mining the exact same amount. When you add these two together, 2,500 plus 2,500 is 5,000, right? 80 plus 80 is 160, right? So 160 plus 5,000 is 5,160. So this dashed line is 160 from this vertical line here at 5,000, right? That's the competitive equilibrium, right? So when the quantity supplied, which is the sum of those two, 5,160, the most consumers will pay for that lithium hydroxide is $76 per kilogram. Okay. That's the competitive duopoly. When you have two firms and only two firms, they're identical, and they compete against each other like they do in the perfectly competitive market, you maximize total surplus, which is the sum of this triangle and the sum of this trapezoid here. You maximize that at the competitive equilibrium. We call that efficiency, right? So competitive markets are said to be efficient because total surplus is maximized. Okay. Now in the cartel model, the firms, well, because the firms in a competitive market earn a zero economic profit, over the long run, there's an incentive for them to cartelize into a monopoly. Now, the identical firms do this by agreeing to self-imposed output quotas. Since the cartel is the market, its marginal cost curve is market supply. Its marginal revenue equation, so this is the monopolist, in this case, the cartel's marginal cost curve, right, which is market supply. Market supply and marginal cost of the cartel are identical, right? All we did is we replaced P with MC, right? MC from monopolist marginal cost, right? Now its marginal revenue equation has the same intercept as the demand curve, but it's twice as steep. So this right here is the intercept of the demand equation, right? And then this is the steepness of the market demand curve. The marginal revenue curve is twice as steep as the demand curve. And you can see that right here. The difference between this model up here and this model here is the fact that we're drawing the marginal revenue curve in here, right? It has this same intercept and it's twice as steep as the demand equation, right? And the way the cartel works is that because the firms are identical and they agree to split this market equally, right? The monopolist, in this case the cartel, will maximize their joint profits if they choose an output level where marginal revenue, the red line, equals marginal cost, the black upward sloping line. And that occurs at this value here, right? So in a competitive equilibrium, the two firms supply just over 5,000. But acting as a cartel, acting like a monopoly, the cartel restricts output to drive prices up the demand curve. And the monopoly price is $110.40 in my model, right? So they're pushing the price up the demand curve by creating an artificial scarcity, right? Now, this value here, the value of output of the monopoly or cartel, right? They split it, right? So firm one is producing that much lithium hydroxide, and firm two is producing that much lithium hydroxide. Together, when you add those two up, you get 3,440. So this value here is 3,440 because I'm adding these two values. 17 plus 17 is 34. 20 plus 20 is 40. So this value here would be 3,470, right? Now, in the last one, this is not a model that we've covered in class. We covered this model in class a couple of times. We covered it with unions. We covered it with a firm that buys up its competitors. And we did this one a lot. we did the competitive outcome a lot, right? What we haven't discussed is this Cournot model. So in the Cournot model, the firms do not explicitly include, but they correctly anticipate their rivals' decisions. Now, this is not hard to do since the firms are identical and their managers are too, and they're free to visit. You know, they can go and look at what their competitors do. It's like a gas station, right? A gas station owner can drive around the community and see the prices that his or her competitors are charging the consumers, right? So it's not like this information is hidden, right? Because these firms are identical and their managers and owners are assumed to be identical, it's not much of a stretch to understand how this, how they can correctly anticipate what the rivals are doing, right? The resulting market outcome is called a Cournot market. In it, firm one's choosing its quantity based on what it believes firm two will produce. And it can be shown that firm one's marginal revenue and marginal cost are these two equations, right? This green Q2, well, that's firm two's choice. This is firm's one choice, right? Firm one chooses its output based on what it believes firm two will do. So firm one has taken this as a given. And then based on this being some number that it believes will be the outcome of firm two, firm one will then make this choice. Okay. So when you solve these two equations, right? When you solve the two equations and you simplify and you solve for Q1, because firm one is choosing quantity one, right? So when you solve those two equations for Q1 simultaneously, this is what you get, right? And this is called a best response curve. It is firm one's best response to firm two's output decision. So firm one is guessing what this is and then holding a constant. Based on what it guesses that to be, then it can choose what this will be in order to maximize its profits. Now, because these firms are identical, right, all we have to do to get firm two's best response curve is just to swap out the coefficients, right? So I erase one and put two down here. I erase two and put one down here. And then this is firm two's best response to firm one's decision, right? So firm one does this, firm two will do that. And then I'm going to graph the two equations down here together. Now this is Q2, right? This is Q2. And this is Q1. Okay. Actually, this is firm one, right? Firm one's intercept is 2580, right? So this line is firm one and this line is firm two, right? And this axis is Q1 and this axis is Q2, right? And we know that because of right here, right? 2580, when Q2 is 0, that right there is all 0. And firm one would choose an output of 2580, which is right there. So this is firm one's best response curve, and this is firm two's best response curve. And notice they're mirror images of each other, right? Now, the identical firms selling an identical product split this market equally, resulting, now that's just because they're identical, right? The identical firms selling identical product split this market equally, resulting in firm one producing 2,064 metric tons and firm two producing 2,064 metric tons, right? They're at this point, they end up this point, right? They end up at this point, right? These come from this value here being split, right? Oh, sorry. This value here is Q1, and this value here is Q2. So Q1 is 2064, which is right here. and Q2 is 2064, right? Now, how did I get the price here? I got the price by doing what? By adding these two together, right? By adding these two together, I can plug them into the demand curve up here, right? I can plug them into the demand curve up here. Okay. When you add those two values together, which is 20 plus 20 is 40, 64 plus 64 is 128. So when you add these two together, you have 4,128. When I plug 4,128 into my demand curve, right, I get a price. Now 4,128 is right here, right? So the Cournot price is higher than the competitive price. We'll do it here. 4,128 is right here somewhere, right? So the monopoly price is 110.4. The Cournot price is in between the monopoly price and the competitive price. So the Cournot price is in here somewhere, right? Where the quantity is 4,164. Okay. Now we're going to use all that modeling to build this profit matrix, right? We're going to use all that modeling to build this profit matrix, right? Okay, so what we're going to do over here is we're going to calculate various profits, right? Let's go down the diagonal first. We'll start with the competitive outcome. This third column in this third column and third row, right? Firm 1 is producing 2,580. Firm 2 is producing the same amount, 2,580, right? That's the competitive outcome up here, right? That's this competitive outcome up here. And the price is $76, right? Okay. So we're going to calculate the profits of this outcome. And remember, there are zero economic profits in the long run, right? Both firms know that. Okay. So I'm going to replace my outputs here to the competitive duopoly. Notice when I do that, this adds them up and I get 5,160. This generates the price of 76 because Desmos is plugging this quantity into that value right there to get a price of 76. This is just rounding, making sure that the price is rounded to 2 decimal places, which in this case, it doesn't matter, right? This calculates the cost of firm 1. This is firm 1's output, right? And this is firm 1's cost of production. This is firm 2's cost of production. When I subtract the price and firm 1's output, I get a revenue of $196,080. And I get the same amount for firm 2 because they're identical, right? And the revenue minus cost here is my profit. So in the competitive equilibrium, the profit of both firms is 0, right? And this leads to the firms wanting to collude, right? So let's go to the collusive model. In the collusive model, because we have 0 economic profits, right? The firms want to collude. And they collude again by doing what? They agree on output restrictions. Both limit their output to 1720, right? They're going to split the market as a cartel, as one firm. They're going to act as one firm and restrict output. Now, firm 1 could buy firm 2 and just become a monopoly. But maybe a government prevents that from happening, right? Maybe the government prevents firm 1 from buying firm 2 or firm 2 from buying firm 1, right? So they're gonna act as a cartel, right? They're gonna act as one firm. So that cartel model's in the middle, right? And we said the price was 110.40, right? So what we need to do now is we need to replace the quantities with the cartelling outcome, monopoly outcome, 1720 and 1720. Together, each produces 1720 per their cartel agreement. That restricts output creating an artificial scarcity, right? When this value of output for the market is plugged into the market demand curve, we get a price of $110.40, right? This again rounds it just in case this is a unrounded number, right? With it, so that just rounds it. This calculates the cost of producing these two outputs, right? Firm one's cost of producing 1720 and firm's two cost of producing 1720, right? They're both identical because they're, again, these costs are identical because the firms are identical. This multiplies the quantity times the price. This multiplies firm two's quantity by its price. It's the same as firm one. And then this calculates the profit. So if they collude to act as a monopoly, Control C that, you can earn an economic profit. Those economic profits are substantial, aren't they? Right? Oh, yeah. The orange outcome here, this orange outcome is the competitive outcome, right? 2580 for both firms with zero economic profit. So this outcome here represents zero economic profit for both firms. This outcome is the monopoly outcome. It represents economic profit of 44,376 for each firm, right? And so you can kind of see that as you move from here toward the origin, things are becoming more scarce. As things become more scarce, the profit rises, right? The profit reaches a maximum at this point. So three-dimensional, you can think of this as when I go from this point to that point, I'm going down like a parabola, right? This is at the zero height, and this is at the 44,376 height, right? And then profit falls this way, right? So you can think of profit rising, peaking, and then falling to that point, right? So let's find the other values of the profit matrix. So we're going to leave quantity one at the monopoly output. We're going to change quantity two, or sorry, we're going to leave quantity two at 1720. We're going to leave this one at 7. We're going to hold quantity two at 1720, and then we're going to increase quantity one to 2064.
But we're going to go to the military. Sorry, it's 520.
Okay, so I have two different outputs now. We're holding firm two constant at the monopoly output, and we're letting firm one renege on its cartelling agreement. That results in a profit. If you go down here, it results in a profit, a big profit for firm one, right? Firm one's profit is 51,176.16 cents, right? Firm two got punished by this, right? Its profit is only 32,542.40, right? So its profit went down. When firm one cheats, its profit goes up. Firm two doesn't cheat on its monopoly agreement, cartelling agreement. It gets punished, right? All right, let's go further. Let's reduce or increase firm one's output to 2580. When we increase firm one's output to 2580, it further cheats on the cartel agreement. Firm two is holding steady on that cartel agreement. What are the profits? Firm one's profits are 240,156. And oops, sorry, that's revenue. 160,304. Sorry, I'm looking at this wrong. His profits are 44,376. All right, I guess I'm just going to type it in. And firm two's is only 14,792. So if firm two stays at 1720, firm one's best option is to go medium output. So firm one believes firm two will stay at the cartel agreement. Its best move is to do a medium output, right? Its profits are maximized. Here we're holding firm two's output constant. Its profits shrink as firm one increases its output, right? So firm one's best move, if firm two does 1720, firm one's best move is 2064 medium output, right? So let's go now to the situation where we're holding this 1720 and we're going to hold firm one's output constant at the cartelling agreement. And we're going to let firm two cheat on its cartel agreement. Firm two chooses medium output. In my model, it's 2064. What are the profits? The profits have just flipped, right? They've just flipped, right? They just flipped from, because they're identical firms, right? They flipped here. And the same will be said if we increase firm two's output 2580. If we increase firm two's output 2580, again, these two profits have flipped. These are identical firms. Right, so what this says is that if firm two believes firm one will stay at the cartel agreement, low output, firm two's best response is medium output because its profit will rise from this cartel profit to 51,476 and 16 cents. But then if it goes to even higher output, its profit drops off. So if firm one stays at the monopoly low output outcome, firm two's best response is to go medium output, right? All right, let's finish up the values in the middle here. So in the middle, both firms are producing 2064. And both earn a profit, economic profit of $37,275.84. Right? Then all we need is the outcome where we keep this at medium profit and we change this to high output, or high output, 2580 in my case. So if one is at medium output and the other's at high output, the profits are higher so firm one's profit is almost 16,000. It's at medium output. And firm one is at medium output, its profit is almost 16,000, right? And then we got higher profit, right? We're able to finish off the, got them backwards. I'm kind of rushing through this. I'll review it here in a second. Okay, so this should be the 16,000, right? Roughly 16,000. There we go. All right, cool. All right. So when firm one goes medium, firm 2 goes high output, firm 2's profit is greater than firm 1's profit. So firm 2 goes high output and firm 1 stays at medium output, firm 2's profit is more than firm 1's. If the opposite is true, if firm 1 goes medium output and firm 2 goes high output, firm 2's profit's gonna be higher than firm 1's profit's gonna be higher than firm 2's, right? Now, if firm 1 is sure that firm 2 will produce low output, if firm 1 is sure that firm 2 will stay at low output, will adhere to the cartel agreement. We already said that firm 1's best response is medium output, right? 2064. Its profits are maximized and it goes medium when firm 2 goes low, right? Firm 1 is sure that firm 2 will produce 2064. So firm 1 believes that firm 2 will stay at 2064. What is firm 1's highest profit? Again, it's at medium output, 2064. Firm 1 is sure that firm 2 will stay at high output, right? Where is firm 1's profit maximized? Firm 1's profit is maximized again at medium output. Okay, now if firm 2 is sure that firm 1 will stay at high output, where is its profits highest? Its profits are highest here when it produces 2064. Firm 2 is sure that firm 1 will stay at 2064 medium output. Where's firm 2's profit the highest? Again, at medium output. $64. And then finally, if firm 2 is sure that firm 1 will stay here, where's firm 2's profit the highest? It's highest when output is 2064. So what this suggests is, it suggests what? It suggests firm 1 has a dominant strategy of producing medium output. And firm 2 has a dominant strategy of producing medium output, right? Now, although the firm's profits are collectively the highest when both collude to produce 1720, collectively the profits are the highest here, right? We're talking like 88,000 here. Here, collectively, the profits are 83, right? Here, the profits are collectively 88. So both firms produce 1720 high output. The incentive to cheat on the agreement between the firms yields a Nash equilibrium of what? Well, the Nash equilibrium is 2064, right? Why? Because given any decision of firm 2, firm 1's profits are maximized when it chooses 2064, right? And the same goes for Q2 or firm 2, right? This is why cartels don't last for the long run. They might work in the short run, but they don't last unless the cartels can take their if the cartel uses their surplus, their increase in the surplus they get from acting as a monopoly, they use that to purchase favors from government, and they can protect their cartel, right? They can use government to protect their cartel. And it looks like we got everything correct. All right. So that's game theory as it relates to an oligopoly. In this case, a duopoly of very few number of firms, 2.